the part of a model that changes over time as it undergoes training or retraining once we want to improve it after it's being used in production, the part of the model that changes, is it the data structure? Is it the code, the logic within the model, or is it both?
So just to clarify, the code, there won't be any code within the data structure or within the model itself. The code is just there to call the model and make it work. The actual model is just that complex data structure. So
I
when you
see.
retrain it, when you retrain it, then basically you are readjusting those weights, if you can relate back to our analogy. So it's internally then there would be, let's say, some bits that would get changed within our data structure. And then it would be a different, just imagine it's a big blob. And it gets, again, with not going into too much details, but it gets stored in a specific manner.
Mhm.
However, some bits would change as a consequence of our retraining, and then it becomes, let's say, version 2. So it would change its intelligence, and now it would be, let's say, it would be capturing a different type of pattern, say, for example.
Okay. Let me ask you another question, just from a really basic perspective. In our linear regression example, the algorithm provides the formula, um, but the data, we're running it through the algorithm. So by the time the algorithm has processed data, we already have a value associated with y, do we not? Before it reaches the model. Is that correct? Or is the solution to our problem, the value of y, is that determined by the processing that occurs within the data structure of the model? Is the output of the model the result of, is the value of y, or is the output of the algorithm the value of y that the model then further processes?
Now, it's the actual, as part of training at that time, the value of y we are getting, that y is already known at that point in
Known
time.
when? It's known after the algorithm
No,
is done with
no,
it, or?
during our training. So while we are training,
Yep.
both the y and the x, they are both known.
Right.
Only then we know how good or bad we are doing
Right.
during the training.
So here, I'll use my mouse here. This here has the formula. This is processing data using this formula. So by the time this reaches the model, do we know why?
Uh, mm, you can't really separate out, the actual arrow. It
It's
won't.
this here together.
Yeah.
Okay.
So
Okay.
it's more like pictorially you would say that, but in terms of, like, once you have chosen the algorithm, then behind the scenes you have got like a bare bone model that you need to train.
So the model is, it's the model logic processing the algorithm.
In a way, you could say then, so the data would then, let's say, go directly to the model as part of the training, and then it processes the actual data
Okay,
as
so
part
it's
of
the
its
model
learning.
software program that
Yeah,
uses the algorithm as an input to process the input data to produce the data structure that it then uses to produce the results.
yeah. So
Okay,
once it is fully trained, then the model exists as that complex data structure that.
and then thereafter, because it already has the algorithm
Mhm.
as part of its processing scope, it can receive new data and continue to produce new results.
Yeah, I mean, it's just implicitly it has that, because it came from that algorithm. So model has that knowledge of, like, how it should work in terms of the algorithm.
Okay.
So yeah, so it's kind of like a given. It's already inside it, put this way, if you want
Okay.
to.
Last question, Wajid, for today. The process of training. What? So, from what we've learned from you so far, uh, about how the algorithm relates to the model, how they work together. Um, it's about taking data, uh, processing it in a manner so that we get intelligence from that data relevant to our problem. And so we select an algorithm that helps us shape a model and its data structure in the best way possible for us to get the best solution to our problem. Why is it called training? It looks just like a data processing task. We're processing data. The more data we process, um, the more the results are shaped by what we are inputting into our system. What is there? First of all, is there more to the process of training, and why do we refer to it as training?
So again, I mean, going back to our fishing expedition, the until-less we have those like at least a few number of those friendly salmons, we we would have no idea how to best tune our weights for each of the cells within the fishing net. So same goes for our machine learning model. Until unless we have that historical data, that data, until unless we pass that data through our model, it won't have any intelligence. So in order to grow it or develop its intelligence, it needs to look at that data. So and it's different from our, let's say, day-to-day or more like our sort of like data processing, because we are not in a normal data processing. You will take some data in, perform an operation, and here's your output. But in this case, you are not changing the, let's say, the original, let's say, the data itself. You are using that to come up with a decision or come up with some sort of a prediction. So that's why, but to do that business of making a prediction, you need to have captured the patterns that are lying within the data. And for that, you need to do the training.
But is training just another word for data structure optimization or data intelligence optimization? Is that's all we're doing, right? We're just improving the quality of the data that's relevant to our problem.
So, yeah, I think it's so when you say improving the quality of your data or data structure, to start with, within the machine learning world, there is no data structure as such to start with. So to build that complex data structure that we're referring to as data model, we have to pass data and then, in other words, train our model. So unless we do that, we can't achieve that data structure. So to start with, there is no data structure. The model isn't even there.
Mm-hmm. No, I
So
understand.
mm,
I understand. We talked about the fact that we're basically creating a model from scratch as part of this process. Um, I just wanted to understand the process of training. So, the what we refer to as training a model is essentially a process whereby using an algorithm and using input data, we're creating a new data structure and we're continually improving it to produce the best results relevant to the problem we're trying to solve. Is that it? Is that what training is? Or is there anything more?
yeah, in a nutshell. But just I think it's a little bit, again, it's probably the just it's a little bit of a oversimplification that
Okay.
it's not really a data. At the end of the day, we don't really talk about having a data structure within the machine learning kind of a world. It's always about the model. It's just in terms of in its very basic form. How does it? If you look at the model, how does it look like? So at its very, very basic level, it's some sort of a data structure.
Hmm.
But to get to that, you can't define that data structure yourself. You have to have an algorithm, and then you have to go through this process to get to that data structure. So
Quick question. When we train a model, are we always limited to one algorithm, or can you train a model using multiple algorithms?
no, so one model would be coming from one algorithm. So, however, you can train multiple models based on the same data set. And then that's when we get into the realms of like ensemble learning and, doing like a voting kind of a thing,
Right.
whereby just to choose which model is better. But one model would come from one algorithm.
In our previous example, where we realized we had chosen the wrong algorithm for our fishing expedition, and we had to go back and choose a different algorithm altogether because we realized it was a different or greater problem that we're trying to solve. Would you just then abandon the model you had trained and deployed previously and start from scratch, or would there be any benefit to bringing in a new algorithm and working with the model that had been previously trained on a different algorithm?
So I think it all depends what type of machine learning you're doing. So if you are in like the classical kind of like we're using one of the classical algorithms, then you can still keep the old model as your baseline, because whatever new algorithm you have chosen and then you train the new model, you can use your old not so well performing model as a kind of like a gauge. So that can serve as a baseline. Again, you need to determine how good or bad you're doing. So just to make sure that, yeah, I'm doing better than what I was doing before, you keep the old one. But taking this concept to another level, let's say we are like our version A or the very first model was based on a particular architecture of a neural network, let's say. And then we realize that, oh no, we are not getting good results. We need to totally change the architecture. Then again, there's a concept of like transfer learning. And it could be that rather than just totally throwing away your first model, you can keep certain parts of your model and then retrain rest of the model, rest of the, again, we are talking about neural networks and rest of the layers of the model. So you can do a little bit of you have some kind of like width if you're working with neural
Okay.
networks. So
Okay.
yeah, you may not need to throw away your old model. You can still at least keep like the very first few layers and then add new layers based on
And
the
that's one of those decisions our data analyst can be part of, in terms of deciding how this should be, uh, how the overall system should be changed or evolved if we do need to make drastic changes like bringing in a different algorithm. Yeah.
Yeah, yeah. So in this case, your machine learning engineer would look into that. Okay, maybe the model is not capturing the actual concept, the pattern
Hmm.
that's hidden within the data. So the machine learning engineer might need to introduce few more, like make the model more complex, like the architecture of your neural network more complex by introducing more hidden layers, say for
Okay.
example. So then that's the decision that, yeah, the machine learning engineer would take.